Question number 4 then, and we're given 4 statements. 2 ways you can do this really. You can rule out 3 of them, or you can just go straight for the one that you know to be correct. So for question 4, it's talking about the characteristics of an object moving in a circle with uniform speed. So there's our situation there. There's our particle going around the circle with uniform speed. The first statement, we're going to see if we can try and prove or disprove it, is the kinetic energy of the particle is constant. Well, we know the kinetic energy of the particle is given by EK equals half m v squared. The mass of the particle isn't changing, and the velocity isn't changing, or more specifically the magnitude of the velocity isn't changing. Don't forget that kinetic energy is a scalar, so we're not interested in the direction of this velocity. So straight away we've actually proven that the statement A is actually correct. This kinetic energy thing is not going to change throughout, but just to be clear, we can rule out the other 3 options. Option B says the force of the particle is in the same direction as the direction of motion of the particle. That's not true. For this point, for example, on the path, the force is going to be always towards the centre. Force is always towards the centre in circular motion, but the direction of motion of the particle is in this direction, so they're at 90 degrees to each other. The momentum of the particle is constant, is your option C. Momentum is given by mv, but this time remember momentum is a vector quantity, so whilst the magnitude of the momentum will be constant because the mass and the velocity are, that can't be said for the direction of the momentum. So momentum is always going to be changing as the direction of the particle changes, so that one can't be correct either. And finally, the displacement of the particle is in the direction of the force. A bit of a trickier one, perhaps, to put this one out. But take this one, for example. If we say that this side is positive and this side is negative in some sort of coordinate system, the displacement of this particle is certainly positive, but the force is acting in the negative direction. So the displacement of the particle is not in the direction of the force. So none of those 3 options can be correct. As we said, we already proved that EK is a half mv squared, so A is going to be the correct option.